Let's continue studying molecules with multiple chiral centers. And this is the case of the molecule that I drew here. And we're going to be studying today a stereoisomeric relationship. So relationship between molecules. Let's see what's that. First, as we see here, we recognize that we have three chiral centers. We have here the one that has the OH, here there's three, right? And we know that because we have four different substituents in each of the carbons. Now, for that, we can determine the absolute configuration, and at this point, we should be a little bit more familiar with that. So for the carbon on the top, we would say priority one is the oxygen, highest atomic number. Then we have the chain that goes down, because here we have a carbon attached to carbon and carbon. And then last, so priority three will be on the top, because here the carbon is attached to two hydrogens. So I'm going to say priority one, priority two is below priority three. So this is R, that center. Then for the carbon here with the metal group. So now we have, and again, it was easy. In this molecule in particular, I have a hydrogen pointing back to the back, meaning I'm looking at this the right way. So in the carbon that has a metal, then I am in between a chain here, a carbon with an oxygen, or a carbon attached with a chlorine. Chlorine has a higher atomic number, so that would be my first priority. So priority one is with the chlorine, then I need to go up to where the OH is, and then to the metal. So what we did here is we have rotated, and let's grab another color here. So from the chlorine, that was my priority one, priority two, priority three is a metal. So also the rotation was clockwise, so it is R. And let's do the last one. For the last one, we have carbon has higher priority is the chlorine. Then the change to this side, because here you have a carbon attached to metal and another carbon, and here is just a carbon with another carbon and two H's here. So priority one is chlorine, then the chain to, say my left, to here with a metal. Let's go 1, 2, and 3. 1, 2, and 3. Notice that now the rotation was opposite. So this is now the S configuration, right? So because of what we learned when we have the enantiomer to that molecule, there's two ways of drawing that, but I'm choosing now to draw the molecule exactly as it is, but I'm going to here in every other, at every chiral center, I need to invert the configuration to draw the enantiomers. So enantiomer, and in doing that switch, I'm switching oxygen and hydrogen. That's not pictured. So now the oxygen is going to go on a dash, invert the other center. So metal is going to be on a dash as well. In here, chlorine. So again, you have inverted the three centers. So this two molecule, the relationship between these two is that they are enantiomers. And also we know that the enantiomers will have the opposite configuration. So if this was RRS, then here it will be SSR, the configuration. Now, let's say that I have, instead of this drawing, I'm going to do another, and this time I'm going to change it a little bit, this, and I'm going to say this is OH, and this again. But I'm going to keep that chlorine here on a dash. Now notice this is not the enantiomer again, because the enantiomers will have the opposite configuration at every chiral center. And so we have inverted relative to the first one, we inverted this two, but the other is the same. So the relationship between these two molecules is diastereomers. Remember that mirror enantiomers are related as mirror image, but they're not superimposable. If you try you can draw the mirror image to that, and it will be identical to this. And if you try to overlap these two, these actually won't match because these are inverted. But here you have inverted two center and one is not. So when that happens, the relationship between these two molecules is diastereomers. I can draw another diastereomer to the first, and let's say that this time I'm going to say not invert the one with the OH, but I'm going to invert the other two. Again, this is not the enantiomer, so they will be related as, these two are related as diastereomers. And lastly, if I am asked to draw the enantiomer of the molecule above, what I'm gonna do is invert the configuration at every chiral center here. So I'm flipping where you have the chiral center, I'm flipping the OH and the H and so forth. So the enantiomer of the one above would be here. I'm changing the center. Here I'm changing that center. And I need to change the other. Right? So now I have changed this to this box. I relate it as enantiomers. This two I relate it as diastereomers. So here's what we want to see. So again, let's assign configuration here. Notice the two enantiomers. Here was RRS. This is SSR. Now, if we look at that and we were asked to assign configurations, really looking at those is easy. This is the same, so it should be S. This is the same, so it should be S. And this with a wedge is like this, so this is the SSS. And since these two are enantiomers, if this is S, this is the R, and I have it here, and this is S, this is the R, and again I have it here. And now chlorine here is the same as that, so it should be R. And notice that for the two enantiomers, this is SSS and this is RRR. Okay? So this is what you will be doing. So if the molecule have multiple chiral centers, the enantiomer will have the opposite configuration at every chiral center. If only one that's not inverted, then they will be diastereomers. We will be doing more exercises on this.